right, we're only doing half the lesson, so we're going to do 9-4A today. And we're going to talk about finite series. Okay, so we've had sequences, but we haven't had series yet. So let's find out what a series is. First thing we're going to do is we're going to learn a little something called summation notation.
Oh, right, that, yeah.
Yes, sigma, yes. Summation notation. You hate everything today, your face. Your face is like, no, this isn't that bad. All right. Now, suppose that you have a sequence of numbers, okay? Here's a finite sequence. A sub 1, comma, A sub 2, comma, dot, 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 A sub n. That is a finite sequence of numbers, okay? Now, a series is going to take those commas out and put pluses in between them. So a finite series, bless you, is A sub 1 plus A sub 2 plus dot, dot, dot plus A sub n. We're going to add up a finite number of numbers, okay? And the way that we represent this is by sigma, yes. So this is the summation notation. That's what we write. Don't shake your head at me, Sam. And this is, for example, k equals 1 to n for A sub k. Okay, it's the capital letter, Greek letter, sigma, which means sum. And this is, if you were to take this, you would do A sub 1, you plug in k equals 1, that gives you A sub 1. Plug in k equals 2, plug in k equals 3, all the way until you get to n, which is our top ending number. Okay, I know it feels super great in here, but my projector disagrees. It's my new projector. Well, it's not new. It's new to me. When I was in 3rd grade, my parents got a new car, and I showed this boy I liked. I'm like, oh, look, my parents got a new car. He's like, that's not new. It was new to us. It wasn't new. Okay, here we go. So let's do one. Let's evaluate. Let's see if you guys remember how to do these. Number 1. Shh, quiet. Evaluate. And these were weird last year because you were like, what is this even asking, right? So we're going to sum up the numbers from k equals 1 to 5 of 3k. Okay? And there's some ways to do this. First way is just write them out and add them up. It's only 5 numbers, right? So plug in 1 into this. What do you get? 3. Then plug in 2. Then plug in 3. 9. Plug in 4. 12. Plug in 5. 15. And add those numbers together. What is it? 70? Is that your guess? I don't know. I don't think that's right. For some reason. It's 45. You were super close. Okay. Now, letter B. Let's do another one. Let's do the summation. And you know, you don't always have to start at k equals 1. Let's start at k equals 5 this time. K equals 5 to 8 for k squared. And if it's nice, easy numbers like this where there's only a few to plug in, then it's, you know, it's doable. You can do it. You can do it by hand. 5 goes in. 5 squared is 25. 6, k equals 6. 6 squared is 36. K equals 7, 49. K equals 8, 64. Did you notice here that I added up, how many numbers did I add up? 4. From 5 to 8, there are 4 numbers. You plug in 5, 6, 7, 8. 4 numbers, okay? You can subtract. You can go 8 minus 5 is 3, but you have to add 1 because you've subtracted 1 off. Like when you look at this one, you know from 1 to 5 there's 5 numbers. But if you do 5 minus 1, you only get 4. You have to do and 1, okay? What'd you get? Did you add those up? 174? Thank you. 174. Okay. Did you know your calculator also has this feature on it? Yeah? No? The newer calculator does. The older calculator does too, but the newer calculator does. I'll show you that. All right, last one, letter C. Now, this is getting us ready for tomorrow. Tomorrow, we're going to do this. K equals 1 for 3 over 10 to the K, and we're going to do this to infinity. Oh, it's going to take us forever. Little math joke there. Thank you. All right, when you plug in 1, what do you get? 3/10, right? What is 3/10 as a decimal? 0.3. Then you plug in 2, and you get what? 3 over 100. What's 3/100ths? 0.03. Then you plug in K equals 3, and you get 3/1000ths, which is 0.003.
Where it's going.
Do you?
Yeah.
Isn't that so cool? So if I line it up like this, it's even better. 0.3, 0.03, 0.003. And if I do that an infinite amount of times, what do I get? 1/3. Or 0.3 repeating. It's the same thing. It's the same thing. You get 0.33333. Because we do it forever, it actually will converge to 1/3. Eek! We're going to do that tomorrow. Oh, such an exciting day. Don't miss it. You want to be here for that. Okay, now let's talk about some finite sums here. And we're going to do arithmetic finite sums. Arithmetic finite sums. Okay, I've got a little story to tell you. It's a good one. You may have heard it before. It's about my favorite mathematician. Do you have a favorite mathematician? Me. No, I'm just kidding. Mr. Bexford. Yep, you're right. Okay, here it is. Mr. Bexford emailed us last night and told us, hey, happy consecutive prime day tomorrow. Seriously, it is. These are prime numbers, and they're consecutive, and that's today's date.
What's consecutive?
In a row.
Okay.
So, like, prime numbers would be, one's not prime, but 2, 3, 5, 7, and then 11, 13, 15, 17, and it goes in a row. So that's today. It won't be for a while. Long time, he said. Yeah. Okay. It says here, one of the most famous legends in the lore of mathematics concerns the German mathematician Carl Friedrich Gauss. Have you heard of Gauss?
No.
Oh, he's my favorite. 1777 to 1855. That's when he was alive. His mathematical talent was apparent at a very early age, like you guys. One version of the story has Gauss at age 10 being in a class that was challenged by the teacher to add all the numbers from 1 to 100. So he's sitting there, he's a little kid, and his teacher, she probably has some work to do, so she tells all the kids, sit down and add up the numbers from 1 to 100.
He uses summation notation.
He didn't, but he uses, summation notation wasn't around at that time. All right, while his classmates were still writing the problem down, Gauss walked to the front of the room to present his slate to the teacher. The teacher, certain that Gauss could only be guessing, refused to even look at his answer. Gauss simply placed it face down on the teacher's desk and declared, "There it is," and returned to his seat. A little punk. Later, after all the slates had been collected, the teacher looked at Gauss's work, which consisted of a single number. It was the correct answer, and no other student got it right, as the legend goes. Now, what in the world did he do? This is what he did. I'll show you.
Did he go to the future and get a calculator?
No, this is the 1700s.
Oh, okay. So like,
He did. He took the entire row. I don't know how he did this in his head. I always thought he wrote it down on the slate. But he did 1 through 100, and then he wrote them backwards. 100, 99, 98, all the way to 1. And what he did was he added them up, and each one makes the same number, which is what? 101. And how many of 101s are there? No, there's 100 of them. Okay? But you have to divide by 2. And so the answer is 50/50. Crazy. He was 10. He was a prodigy, so don't feel bad about yourselves, okay? He was a crazy, like, mathematician guy. He ended up doing a lot of things that were amazing. He was great. The Gauss elimination method, which is one of my favorites. Okay, anyway, so what we're going to do, though, is we're going to take this and we're going to make it into a formula that we're going to use for arithmetic. Now, don't forget, arithmetic sums are the ones that have a constant difference between them. This is an arithmetic sum, okay, because it's just add 1, add 1, add 1, add 1 to get to the next one, okay? So arithmetic sums are always going to be linear. They're linear formulas, okay? And they have a constant difference. Constant difference. So here's what it is. If we have an arithmetic and we're trying to sum up the numbers from 1 to n for our arithmetic formula, explicit formula, then this would be equal to n times, well, your book does it that way. I like to do n over 2 times a sub 1 plus a sub n. So you take the number of terms that you're adding up, divide it by 2. You take the last number and the first number and multiply by their sum. Okay? Or the book also gives you this one, which is an interesting formula, I thought. N over 2 times 2 a sub 1 plus n minus 1 times d. I don't like that formula. It bothers me. There's too many things in it. But it's true. So let's see. Let's see if Gauss's formula, or not Gauss's formula, if the numbers 1 through 100, if we wanted to add up 1 to 2 all the way out to 100, if it works in this formula. Okay? So this is an arithmetic series, and n equals the number of terms we're adding up, which is 100. The first term is 1, and the last one is 100. Look, it's right there. 101 times 100 of them, and you divide it by 2 because there's twice as many. Isn't that so cool? I don't know if he realized that there was a formula at that point. He did it on his own, which is awesome. Okay, so let's do some problems now. Number 2, we're only on number 2. Number 2 says that a stadium in the corner of it has 8 seats in the front row, 8 seats in the first row, and each row has 2 more than the one before it. And each seat has 2 more than the one before it. Do you ever do this? Like, I do this at weddings sometimes. I want to find out how many people are there. And so I'll just like count the seats and do an arithmetic sum. No? Nobody does that at weddings? No? Okay. They say here that the last row has 24 seats. So how many are in the section? Okay. Now, how many in the section? What they love to do with these problems, they love to give you not all the information. You have to find some of it. Okay? So sometimes they won't give you the number of rows. Sometimes they won't tell you what the last row is. You know, they give you certain pieces. You can find the other ones that you need. But we're going to need n over 2. The first row has 8 and the last row has 24. So we need to figure out how many rows there are. Okay? All right, so how would we want to do this? Well, when you're going to do these problems, you're going to use the explicit formula. Okay? So explicit formula for this would be a sub n equals a sub 1, which is 8, plus the common difference is 2 times n minus 1. Okay? So there's the formula. Now, if I want to find out how many rows there are, and the last row has 24, then I need to find out what n is, and I can plug 24 in for a sub n. Were you thinking that? Yeah? So 24 goes in for a sub n, and I have 8 plus 2n minus 2, and I want to find out what number row like that one is that has 24 in it. So then I would get 6, subtract that over to the other side. What is that, 18? Equals 2n, so n equals 9. Now, that's a really small number. You probably could have figured it out. But if there's like 1,000 rows or something, you don't want to write them all out and try and figure it out. So now I can go and say the total number of seats is going to be 9 over 2, 8 plus 24. Okay, let's figure that out. 9 divided by 2 times 8 plus 24. So in that section of the stadium, there are 144 seats. There you go. Okay, let's do one more. Number 3. Now, suppose that I give you this problem to do. K equals 1 to 50, 2k minus 4. Now, some of you guys are going to take your calculators out and you're going to plug it in. That's nice and good, and yeah, you got the right answer. But some of you don't have that option. So we're going to use the arithmetic finite sum formula. Okay, this is arithmetic because it's linear. See, 2k minus 4, that's linear. Slope's 2, y-intercept's -4. So let's plug this in. The sum is equal to, we have 50 numbers from 1 to 50. My first number is to plug in 1. What do you get when you plug in 1? -2. And my last number is plugging in 50, which would be?
96.
Good. Perfect. And the rest is just calculator. So you go 50 over 2, so 25 times -2 plus 96. And that gives you 2350. Your calculator will tell you that also. Okay. And finally, the last part is a finite geometric sum. Did you know that was coming? No? Yeah? Finite geometric sum. This one's a little complicated, I think. All right, so here we go. If you're adding up all the terms of a finite geometric series, it would be S equals A sub 1 times 1 minus r to the nth power over 1 minus r. Do you recognize that formula at all? You did it last year. I think you had to memorize it, right? Yeah, I give that to you. I don't believe in memorization. Sometimes. Like when my son comes home with a Bible verse to memorize, I don't tell him I don't believe in memorization. I say, yeah, I'll help you. Okay, number, what are we on, 4? 3? 4. Number 4. I don't know. Okay, suppose that you have 4 -4 thirds, 4 ninths, -4 over 27, ... 4 times -1/3 to the 10th. 4 times -1/3 to the 10th. Okay? And I want to find the sum of this sequence. Find the sum of the above sequence. All right, this looks kind of tricky, but it's not. You have to know what the first term is. You need to know what r is, and you need to know how many numbers you're adding. Okay? So here we go. The sum is equal to, first term I can see right away. A sub 1 is right there. It's 4. 1 minus, do you know what r is?
-1/3.
Perfect. R is -1/3. And how many numbers are we doing here? It looks like 10, but it's not. This part's hard, yeah? There's 11. There's 11 of them. Do you see this right here? This 4 times -1/3 to the 0 would give us this first term. So there's actually 0 through 10 numbers. So there's 11 of them. To the 11th power over 1 minus -1/3. All right, so you need your calculator for this. I'd put parentheses around all of that. Okay, so let's find out what it's going to be. Let's find out. We're doing 11 of them, and they're going to turn out ugly. That's okay. So what I would do in my calculator is I'd go 4 parentheses, 1 minus parentheses negative 1/3 to the 11th power, close those parentheses, and then divide by parentheses 1 minus negative 1/3. Woo! I get about 3, don't I? 3.0000169, blah, blah, blah. Ooh, I wonder what the infinite would be. Tricky. Okay, number 5. Now we're going to write the sum using summation notation, and then we're going to find the sum. So write the sum in sigma or summation notation, and then find the sum. Okay, sigma notation always involves explicit formulas, okay? So let's say that we have 5 plus 16 plus 27 plus 38 plus dot, dot, dot plus 1644. Okay? And I need to first write this in sigma notation and then find the sum of it. So here we go. Sigma notation. Make it easy on yourself. Let it start off with 1. And you can use whatever variable you want. I usually use n. The book likes k. I like n. N equals 1. And now I need to find an explicit formula for this series up here. What's it doing each time? Did you recognize that at all? This isn't geometric, is it? No. It's arithmetic and it's adding 11. Is that right? Yeah? Okay, cool. So we're adding 11 each time. So I want to write a geometric or an arithmetic explicit formula, which I will leave on the board. It's right there. And you can choose either one. It doesn't matter. But a sub n would equal, I'm going to do the second one. What would a sub 0 be? Negative 6 plus 11n. Yeah? Okay, test it. Plug in 4. I get 44 plus negative 6 is 38. Great, that one worked. It's probably right. Okay, so what I would do is I would over here do 11n minus 6. Okay. Now I need to figure out what the top number is. What number am I plugging in? A lot of people like to write 1644 up here, and that's wrong. So if you plug 1644 into this formula, it's not going to be 1644. We need to find out what n gives me 1644 when I plug it in. So I need to take 1644, set it equal to here. So I want to find what number n is. So subtract 6. I need my calculator for this one. 1644, we're going to subtract 6 and then divide by 11. Whoa, that didn't work. Add 6. Okay. Do you ever do that? You make a mistake and then you're like, didn't work, but then you go back and you figure it out. It's pretty good. So 1650 equals 11n. So n turns out to be 150. So you go over here and you plug 150 in at the top, and this entire thing would be your answer. Let's find the sum of it now. Do you have the cool thing on your calculator where you can do it? Yeah? Okay, go for it. I don't mind. Okay, if you don't, that's okay too. The sum would be, I have 150 numbers over 2. First number's 5, last number is 1644. And that's equal to something. 150 over 2. 5 plus, lots of calculators in this. 1, 2, 3, 6, 7, 5. There you go. Okay, let's do one last one. Number 6. Ooh, I didn't give you any time. I'm sorry. It's a longer lesson than I thought. All right, it says to find the 9th partial sum. Find the 9th partial sum. Let me tell you what that means. Suppose we have negative 1/4 plus 1/16 minus 1 over 64 plus 1 over 256 plus dot, dot, dot. And they want us to find the sum of the first 9 numbers. That's what, see, this is an infinite series here, but they want us to stop at 9, okay? All right, so we have to decide, is this arithmetic series or is it geometric series? In this case, it's what? Geometric, cool. And we're multiplying by negative 1/4. Oops, why didn't I do that? We're multiplying by negative 1/4 each time. Okay, so that's what R is. R is negative 1/4. N is the number of terms that I'm adding up. They told me to do 9. And my first term is negative 1/4. So the sum equals negative 1/4 times 1 minus R to the 9th power over 1 minus R. Okay? So let's see what that is. I really think a lot of times the hardest part on these is getting it right in your calculator. 1 minus negative 1/4 to the 9th power. It's a lot of parentheses, huh? And then divide by 1 minus negative 1/4. You should get, ooh, is this right? What'd you get? Anybody do it? I got negative 0.2. Anybody else? Negative 0.200007629. I don't know. I hope that's right. Yeah? You got that too? Okay, cool. All right.